In this section, we're going to be talking about multiplying and dividing rational expressions. A rational expression is a polynomial fraction. Anything you could do with regular fractions, you can do with rational expressions. So, again, we're talking about polynomial fractions. So, perhaps something that looks like x squared minus 9 over 2x squared plus 3. Okay? Ugly stuff, but we're going to make this pretty simple and easy. The key concept here is to focus on factoring. Take a minute to press pause and copy everything you see right here. Okay, so what we're going to talk about here is in this section we're going to simplify, multiply, and divide rational expressions. Very quickly I'm going to run through this video. First of all, a rational expression is in simplified form if the numerator and the denominator have no common factors. We're looking to cancel out anything that's common so that in the end our end answers have no common factors. Let's see what we're talking about with basic fractions first. Here we have the basic fraction 24 over 36. If you take both top and bottom and factor them up a little bit, so let's see, I say, well, 6 goes into 24, so 6 times 4 is 24, and hey, 6 times 6 is 36, and 6 divided by 6 is 1. I'm left with 4 over 6, but then you say, well, wait a minute, 2 times 2 is 4, and 2 times 3 is 6. That cancels out to be a 1, leaving us with 2/3 as a final answer. Some of you might have said, well, wait a minute, Mr. Brecklin. 12 times 2 is 24, and 12 times 3 is 36, and 12 divided by 12 is? Yes, 1, leaving us with 2/3 as the answer. The key thing to walk away from this moment is to realize that factoring all the way is the best method. How you get there sometimes is a multi-step process, so there's more than one road to get there. Okay, now let's continue on to rational expressions. As it says above here, simplifying a rational expression usually requires 2 steps. First, factoring, then dividing out any common factors. So when we factor out the top piece here, common factor, right, my rule of thumb, pull out something common first. X is in both terms, so you're going to be left with x plus 7 over x squared. And I'm just going to write x squared like this, sort of factoring apart the x squared. Now what can we cancel out? X divided by x is 1, leaving us with a final answer of x plus 7 all over x. And that's our final answer. Don't try to cancel out these two x's. This is held together. That's one factor held together by addition, and it's an implied parenthesis, so you can't divide out the x's. It doesn't work. That would be like saying 2 plus 3 over 2 is worth 3. Is 5 over 2 equal to 3? I don't think so. So don't try to cancel out those x's. Our next example, x squared minus 2x minus 15 divided by x squared minus 9. First, look for common factors, top and bottom. Nothing common I could pull out. But on the top, I can factor that trinomial. That's x minus 5 and x plus 3. Now this is great because we're practicing some skills that are needed on other questions in the final exam. And x squared minus 9 is x plus 3, x minus 3. That's a no-brainer. And look what we have. On top and bottom, a common factor. So those two cancel out, and we're left with x minus 5 over x minus 3 as a final answer. That's that. Okay, so this is the part where you're going to start working on your own. You do 1 through 6. I'm going to do number 2 for you. Do 1 through 6 first, then check back. Press pause. As I look here, I've factored out a 20 out of the top, which is my greatest common factor. Leaves me with a 2x plus 1 on the top. On the bottom, I factor out a 10, so that's the greatest common factor on the bottom, and I'm left with x, or 1x, plus 3. And I have no major common pieces here. I guess, we're going to look at this 10 and 20. But as far as the 2x plus 1 and the x plus 3, there's not much I can do there. So that's going to stay. And I'm going to keep them in parentheses. The 20 divided by 10, of course, is a 2. So not real exciting for this one, not a lot canceled out, but something did, and that's the key. You do the rest, check in with me next class. Moving on to multiplying and dividing now. Okay, take a minute, copy down everything in the blue box, including the definition. Take a minute and read it after you copy it. It'll help, I promise. Okay, now that we put that aside, let's talk about our new problem. What is the simplified form of 8x to the third y divided by yada yada yada? How are we going to approach this? The same as if we were going to approach, say, 2/3 times 10/12. You know, I would look for things that I could cancel out and then multiply straight across and see what I have left over. If what's remaining here is reducible, then I continue to reduce there. You see the 10/6 was reducible, but now I got 10 over 18, which reduces to 5/9 as my final answer. Let's see how it plays out with rational expressions. First, we have to, or at least I would recommend, since this is multiplication, why don't we combine our terms across the top and our terms across the bottom, tighten this up a little bit. Only get one numerical expression and one lettered variable expression on top and bottom. And what I mean is I don't want the 8 and the 7, I just want 56. I don't want x to the third and x to the fourth, I want what x to the third times to the fourth is, which is 7. We add our exponents. y1 times y to the third is y to the fourth. Clean up the bottom, press pause. Did you get 8x y to the third? All right, well now let's start cleaning up things one at a time. When we reduce 56 over 8, we get 7 over 1. When we reduce x to the 7th over x, remember our exponent rules call for subtraction, I get x to the 6th. And when I reduce y to the 4th over y to the 3rd, I get y. No need to put a 1 on the bottom, it's sort of understood, but I think it's easiest to just look at 7x to the 6y, and it looks like choice B was our answer. Now for this particular example, the cleaning up the top and the bottom is a little bit different. These aren't monomials, so I can't just push it all into one fraction that simply. I really want to take each term in and of itself and factor each one. As I do so, because this is multiplication, I can just sort of write one big factored expression across the top, one big factored expression off the bottom, across the bottom. So factor each expression and see what we got on top and bottom. Press pause. So you should have something that looks like mine so far. Now let's start seeing what we could cancel out. The 3x cancels the 3x, the x plus 5 cancels the x plus 5, and what we're left is 1 minus x over x minus 1 and x minus 4 up on the top here. Well, wouldn't it be nice if the x was negative and the 1 was positive? So what could we do? How about we factor out a negative 1? That changes that. And now I have a negative x and a positive 1 on top and bottom, so they cancel. And what am I left with? X minus 4 all over negative 1, which is the same as negative x plus 4 as a final answer. How about our next adventure? The fraction on the right isn't really a fraction. Okay, now it is. What do we do now? Same thing. You attempt to deal with this one. Press pause now. So what happened here? We ended up with this x squared plus 3x plus 9. That's not factorable. X plus 2, that's not factorable. So they stayed, right? But down at the bottom here, this x to the third minus 27, that was a perfect cube. So looking at our perfect cube factors, a minus b times a squared plus ab plus b squared. So boom, boom, they cancel out. We're left with x plus 2 over x minus 3 for a final answer. And of course, here's a few problems for you to try. Bring these into class. Almost there. Well, we had to simplify, multiply, and now we're dividing. Do I really need to say it? Copy all this into your notes. Take a moment. Read what you wrote. It really helps solidify and drive home the information. Then press unpause when you're ready to continue to rock and roll. This is a cool breeze at this point. What are we going to do? we're going to turn this into a multiply and multiply by the reciprocal. We've been practicing adding and dividing, or multiplying and dividing fractions back in the Quizlet stage. Now we're ready to do this like big boys and girls using rational expressions. Press pause and see what you can do with this. Don't forget to factor along the way. This is what I came up with. Now, on the left side here, I got the 7x over 2x minus 10. That's what I factored first, because it's not going to change. The numerator staying up top and the denominator staying at the bottom. So 7x monomial, not factorable. Down here our binomial, 2x minus 10. It's a easy factor out a greatest common factor kind of business. Pull out a 2, I get an x minus 5. Now, this is a guide, not a guarantee, but since I had this x minus 5, I'm hoping that when this thing comes into the numerator, that maybe, just maybe, it has an x minus 5 in it too. So I just look at this and I say, is x minus 5 times something this? Yes, x minus 5 times x minus 6. Not always working like that, but sometimes in math land and book land it just works like that. This became my denominator, and when I factored out my greatest common monomial, x, I'm left with x minus 6. Now what do? It's like the country line dancing here. It's the hoedown. X minus 5, x minus 5, gone. X minus 6, x minus 6, gone. Who's left? I got my 7x up top, I got my 2, and I got my x on the bottom. Hey, gone, down to 1. 7 halves. All of that reduces to 7 halves. That's right. Beautiful. How about one more for the Gipper? Who is the Gipper? I don't know, but I know we're going to do one more for him. That's over 1, right? So when we change this to multiplication and multiply by the reciprocal, don't forget to keep a 1 at the top. Factor, crisscross, applesauce, see what you can do. Shake and bake. Just in case you were already stuck at the beginning, 3x plus 5 times 2x plus 2x minus 3. There you go, right? I need 2 factors that go to 6x squared, 2 factors that go to negative 15. This gives me a positive 10x. This gives me a negative 9x with a difference of positive 1. Got to remember this stuff. It's going to be on the final. Press pause, see if you can work the rest on your own. So what do we have here that'll cancel out? Hey, 3x plus 5 and 3x plus 5. Boom, boom. How about the 2x minus 3? Not much we could do there, so we got the 2x minus 3 on the top. Then we got an x and a 4x squared, so that's just 4x to the third. That's about it. Well, that's almost about it. Your last 2 problems, 11 and 12. Hang in there, you guys are almost done. This was our last lesson.